Elon Musk is a busy man these days, what with adding Twitter to the list of companies he controls. However, as the proper nerd that he is, he still makes out time for his big interest, space travel. The billionaire is a massive follower of the Voyager aircraft and has stumbled upon a shocking discovery made by the two spacecraft. What have the twin Voyagers discovered this time, and how long can they keep up out there in deep space? In this video, we bring you how Elon Musk just revealed Voyager's terrifying new discovery in space. Elon Musk was a scrawny 6-year-old kid when the two Voyager aircraft were launched by NASA. However, as an adult, there is a lot in common between Musk and the Voyagers. For example, Musk now launches rockets for commercial operations from Cape Canaveral in Florida, where the iconic Voyagers took off from. Even as Musk has passed the age of 50, it is nothing short of amazing that the two spacecraft are still out there in space doing their stuff. At launch, not many people would have imagined the mission to last multiple decades. The planners were actually content with a 4-year mission, but thanks to these persevering spacecraft, we continue to learn new things about the far-out universe. Many people might not know it, but the Voyagers wouldn't have launched had the stars not aligned, literally. In this case, the stars were actually planets, the largest 4 planets in the solar system: Jupiter, Saturn, Uranus, Neptune. The last time this occurred was during the presidency of Thomas Jefferson in the early 19th century. The coincidence of the 4 planets lining up meant that a spacecraft could get a speed boost from the gravitational pull of each giant planet it passed. It is basically like the spacecraft would be tugged along by an invisible cord that snapped at the last second, flinging the probe on its merry way. A NASA scientist calculated that the repeated gravity assists would cut the flight time between Earth and Neptune massively from 30 years to 12. There was just one catch: the alignment happened only once every 176 years. So to ensure the spacecraft reached the planets while the lineup lasted, a spacecraft would have to be launched by the mid-1970s, which was exactly what NASA did. To take full advantage of this once-in-a-lifetime opportunity, NASA built 2 spacecraft instead of 1. The 2 are identical in every way, each is about the size of an old Volkswagen Beetle. To handle all the tasks expected of the spacecraft, NASA equipped the Voyagers with some onboard intelligence. This was basically a computer with just 69 kilobytes of memory, less than 100,000th the capacity of a typical smartphone. It is not even proper to compare it to a smartphone when a key fob used to open the car door has more memory. All the data collected by the spacecraft instruments would be stored on 8-track tape recorders and then sent back to Earth by a 23-watt transmitter, about the power level of a refrigerator light bulb. To compensate for the weak transmitter, both Voyagers carry 12-foot wide dish antennas to send and receive signals. The Voyagers have made numerous discoveries since their launch in 1977, but what has helped them to keep functioning till now? Voyager 1 now holds the record for the most distant artificial object from Earth, billions of miles away in interstellar space. It takes about 2 days to receive signals from the spacecraft. Also, it is now in one of the harshest locations in the universe, with extremely cold temperatures and pitch-black darkness. It also contains an extremely high amount of radiation. As such, not only do the scientific instruments on board need power, but the spacecraft needs to keep itself warm in the frigid environment of space. Solar power is useless here because sun rays do not reach these spacecraft at their location. Instead, they rely on radioisotope thermoelectric generators, or RTGs, for their energy. Each of the Voyager probes carries 3 RTGs. They use plutonium-238 as a fuel source. When the isotope decays, it produces heat, which is converted to electrical energy. Each Voyager launch generating 470 watts at 30 volts DC, but the problem is that over time it degrades. However, that is only one of the few workable solutions that could power the spacecraft for decades. Voyager 1 arrived at Jupiter in March 1979 after 546 days of traveling. Voyager 2 launched some days after Voyager 1 and was set out on a different trajectory. It arrived in July of that year. Both spacecraft were designed to be stable platforms for their Vidicon cameras, which used red, green, and blue filters to produce full-color images. The Voyager spacecraft don't spin much while traveling through space. In fact, their rotational motion is more than 15 times slower than the crawl of a clock's hour hand. This is a deliberate design decision to minimize the risk of blurred images. Voyager 1 started transmitting pictures of Jupiter while it was still about 3 or 4 months away from the planet, and they were unprecedented in quality and detail. The pictures of Jupiter's moon Io totally shocked the scientists because the colorful appearance was completely unexpected. Before the advent of the Voyagers, the assumption was that all solar system moons would be more or less alike, like the Earth's moon, drab and cratered. No one anticipated the wild diversity of moonscapes the Voyagers would discover around Jupiter and Saturn. The Voyagers were also so powerful, at least for the period they were constructed. While more than 1 million miles away from Jupiter, one of their instruments, the Low-Energy Charged Particle (LECP) detector system, picked up what scientists thought were unusual signals. They began noticing oxygen and sulfur ions hitting the detector. The density of oxygen and sulfur ions had shot up by 3 orders of magnitude compared with the levels measured up to that point. At first, his team thought the instrument had malfunctioned, but on further scrutiny, they realized there was nothing wrong. And thanks to the cameras of the Voyager, scientists were able to solve one puzzle: whether Io had active volcanoes. The moon, slightly bigger than the Earth's moon, was confirmed to be the most volcanically active body in the solar system. Before that time, the only active volcanoes we knew of were on Earth, but Io had 10 times as much volcanic activity as Earth. Io's colors and the strange ions hitting Crimigis's detector came from elements blasted from the moon's volcanoes. The largest of Io's volcanoes, known as Pele, has blown out plumes 30 times the height of Mount Everest. Debris from Pele covers an area about the size of France. The cameras on the Voyagers took more than 33,000 images of Jupiter and its satellites alone, most of them presenting never-before-known information. For instance, Jupiter had rings. Europa, one of Jupiter's 53 named moons, was covered with a cracked icy crust, now estimated to be more than 60 miles thick. The 2 Voyagers separated at Saturn, with Voyager 1 hurtling through Saturn's rings and flying past Titan. It then turned north out of the plane of the planets. Voyager 2 proceeded to Uranus and Neptune. It spotted 10 new moons around Uranus and added the planet to the growing list of ringed worlds. However, these discoveries were overshadowed by the tragedy of the Space Shuttle Challenger exploding shortly after launch. All 7 of Challenger's crew members were killed, including Krista McAuliffe, a high school teacher from New Hampshire who was billed to be the first civilian to travel into space. Voyager 2 would reach 2,980 miles above Neptune 3 years later, where it measured the fastest wind ever recorded in the solar system, 1,000 miles per hour. It also confirmed one of the coldest places in the solar system, Neptune's largest moon, Triton, where the surface temperature could drop as low as minus 235 degrees Celsius. Here, ice volcanoes spewed nitrogen gas and powdery particles 5 miles into its atmosphere. Voyager 1 is responsible for one of the most iconic photos of the Earth, and that would not have happened without the insistence of famed astronomer Carl Sagan. What happened was that after the images of Neptune and its moons, NASA was ready to turn off the cameras on both probes. Although the mission had been extended with the hope that the Voyagers would make it to interstellar space, they had decided there would be no photos after Neptune because after the planet, there was only the endless void and impossibly distant stars all around. However, Sagan pleaded with NASA to make Voyager 1 send one last batch of photos. Thanks to his influence, the spacecraft aimed its camera back toward the Earth on Valentine's Day of 1990 and took 60 final shots. The most moving of them was the one dubbed the Pale Blue Dot. It captured the Earth from a distance of 3.8 billion miles. That picture remains the most distant portrait of our planet ever taken. Veiled by one sunlight that reflected off the camera's optics, Earth is barely visible in the image. Our planet doesn't even occupy a full pixel. The Voyagers are still in contact with the control center, but every day they recede between 3 and 4 light seconds. Scientists connect to them using NASA's Deep Space Network, which consists of 3 tracking complexes located around the Earth. Both Voyagers have now crossed what is known as the heliopause as they continue on their journey out of the solar system. Voyager 1 crossed in August 2012, while its twin did so more than 6 years later. However, the two spacecraft can still pull surprises on their handlers. For example, earlier this year, NASA detected Voyager 1 had been sending back mysterious data. The probe's Attitude Articulation and Control System, or AACS, controls the spacecraft's orientation, aligns its high-gain antenna toward Earth, and controls attitude maneuvers. Now, the AACS has sent back data that NASA scientists say does not reflect what's happening aboard Voyager. They are not even sure if the data is not randomly generated. NASA claims the Voyager 1 works well for the most part despite its age, so the team handling the spacecraft are monitoring the signals closely as it continues to determine whether the invalid data is coming directly from the AACS or another system involved in producing and sending telemetry data. They might be able to fix the problem with a software update. This is not the first time the Voyagers have run into problems. In 2017, the Voyager 1's primary thrusters began showing their age. The engineers promptly switched to other thrusters on Voyager 1, thrusters that operated during the mission's planetary encounters some 37 years earlier. And amazingly, the second set of thrusters worked flawlessly. It was another example of the remarkable longevity and ingenious design of the Voyager spacecraft. Voyager 2 now has only 5 remaining working instruments, as some functions have been shut down to prolong the power source. NASA turned off the heater for the cosmic ray detector, which helped to determine when it crossed the heliopause. However, Voyager 1 has had it worse, as only 4 instruments are working. The last 2 Voyager instruments that NASA will turn off will probably be a magnetometer and the plasma science instrument. They are protected in the body of the spacecraft, where they still get some warmth from the heat generated by the computers. Even with all their instruments turned off, the Voyagers will continue to travel through space. They will remain there long after we are gone and may reach our closest star, Proxima Centauri, about 16,700 years from now. Let's hear what you think of the Voyagers in the comments section below.